So here's the introduction to chapter 9.4 and example 7. So the first thing we're going to look at is finding some more Stewart equations. At the moment we've got two from the work we've already done. V equals u plus at and s is equal to u plus v over 2 times t. And from here we can see that the first equation, v equals u plus at, doesn't have an s in it. And the second equation, s equals u plus v over 2 times t, doesn't have an a in it. Right? So we can also find three more formula one without u in it, one without v in it, and one without t in it. The advantage of this is that given any three pieces of information about this constant acceleration motion, we can find the other two. So that's why it's useful to be able to do this. So, first of all, let's see what we can do. Let's first of all look to find the one without t. So to do that, we're going to make t the subject of v equals u plus at. So we get v, subtract the u, divide by the a is equal to t. And now we can substitute in 4t into this equation. So when we substitute in, we're going to have s equals u plus v over 2 times t, which is v minus u over a. Well, like most things we're going to do, we get it on one line, so we're going to multiply through by the denominator, multiply by denominator. Can you see what that will be this time? That's 2a. So if we multiply through by 2a, we get 2as, and then we're left with u plus v times v minus u. Because if we multiply this by 2a, the 2 cancels and the a will cancel to leave u plus v times v minus u. If we expand the bracket, you can use the grid if you need to. u plus v, v minus u, we get uv. V plus v squared minus u squared minus uv. These cancel, so the right hand side becomes v squared minus u squared. We usually rearrange this equation, so we have v squared equals u squared plus 2as is the usual form that's given in. So that's another one that we will need to learn. So we've now got three equations, one without s, one without t, and one without a. Okay, next we could eliminate the v. So we could choose to eliminate the v, so without v, we start with v equals u plus at and s equals u plus v over 2 times t. And we're going to substitute in for the v. So we get s equals u, and instead of v, we've got plus u plus at all over 2 times t. So we've substituted in for the v with u plus at. If we now expand that, we get 2u over 2, it says u times t to give us ut, plus a half at squared. So that is our fourth equation, the one without v. And lastly, we need the equation without u. So again, we've got v equals u plus at, but if we want to get rid of the u, we need to make u the subject. So we've got v minus at is equal to u, and then into the same equation, s equals u plus v over 2t. So we're going to take the v minus at equals u, substitute it in for the u, and we're going to get s equals, and instead of u, we've got v minus at plus v times t over 2. So we've got 2v, v plus v over 2, so it's 2v over 2 to leave v times the t minus a half a t squared. And that is our fifth and final SUVAT equation, the one without u, that you will need to learn. So it might be worth collecting those all together. So we've got v equals u plus at, v squared equals u squared plus 2as, s equals u plus v over 2t, s equals ut plus a half at squared, and s equals vt minus a half at squared. And those are our SUVAT equations which we need to learn. Okay. Right, so we can move on now to the first example in this section. As usual, with an example, we need to read the question carefully. We may need to draw a diagram to collect out the right information and then solve it. So, a particle is moving along a straight line from A to B with constant acceleration 5 meters per second. So as soon as I've read that, I know it's a SUVAT kind of question. The velocity of the particle at A is 3 meters per second in the direction of AB, and the velocity of the particle at B is 18 in the same direction. Find the distance. So we could draw that, or we should be able to do this just by lifting out the information. So we know it's constant acceleration. We acknowledge that. And we're told A equals 5 from the question. At A, which is the first place, so that's going to be our initial speed is 3. At B, the final speed is 18. And we've been asked for the distance s. Just all I've done is read through the question again to lift out the information. So A, U, V and S, we want the equation without t. Yeah, so without t, therefore use, and then we state the equation. So have a look at the list, find the one without t. Hopefully you've picked out v squared equals u squared plus 2as. Substitute in the values, 18 squared equals 3 squared plus 2 times 5 times s. Okay, 18 squared sounds like 324 plus 9 plus 10s. Subtract the 9, we get 315 equals 10s, so s is 31.5 meters. So fairly straightforward.